bucka. Haha. You know the deal.
What we're going to talk about next with linear equations is finding the equations given different pieces of information. The first example we're going to look at is a real-life example. So suppose suppose you're the superintendent for a building, and you need to buy new recycle bins and new garbage bins. And you've got a budget of $1,000, and you know recycle bins cost $4 and garbage bins cost $2, and you want to think about how many of each you want to buy. You want to know how many you can afford if you buy a certain number of one or the other. Well, the first thing we're going to do here, as with most of these cases, is we're going to write an equation. And the parts of this that vary, the parts of this that are different, are the number of recycle bins and the number of garbage bins. Now, it doesn't say anywhere here that they have to be the same amount. So we're going to choose different variables for each of those. And I'm going to call the recycling bins X. So to calculate how much it would cost us for the recycling bins, well, they cost $4 each. So we would multiply 4 times the number of recycle bins. We'll call that X. For garbage bins, we'll call that Y. They cost $2 each, so to calculate how much it would cost us to buy our garbage bins, we multiply 2 times the number of garbage bins, or 2Y. Well, if I want to find the total amount, how much it costs for however many recycle bins and however many garbage bins I buy, I have to add those two amounts together. And I know that since I have a budget of $1,000, I want this amount to equal $1,000. Now, a couple of things to note here. This is a linear relation, so you should recognize this as a linear relation from when we talked about relations in our introduction to relations, and the difference between linear and non-linear relations. So this is a linear relation, but looking at this equation, there's no way to tell what the slope or y-intercept are, because it's not written in that form, y equals mx plus b. So what we're going to do with this example is we're just going to explore this example a little bit by coming up with some ordered pairs. So we're going to choose values for x and find out what y is. So a nice place to start often is 0. If we're trying to understand a linear relation, we want x to be 0 first. So if I substitute that into the equation that we have here, well, we get 4 times 0, because instead of x, so what I'm saying is I'm going to buy 0 recycling bins, and I'm wondering how many garbage bins could I afford then. So instead of writing x, we write 0. And now what we're going to do is simplify as much as we can. And 4 times 0 is 0. So we simplified as much as we could there. So now we're going to isolate y by dividing both sides by 2. And we get that y is 500. So if we buy 0 garbage bins, 0 recycle bins, that means that we could afford 500 garbage bins. Well, what about if we bought 10 recycle bins? Suppose 10 was x. Well, again, we're going to substitute in that value for x. So instead of writing x, we're going to write 10. So there I've gone ahead and solved that equation if x equals 10. So we start by substituting in our value. 4 times 10 is 40. So we get 40 plus 2y equals 1,000. Bring that 40 over to the other side. It becomes minus 40 on the other side. Simplify again. 1,000 minus 40 is 960. And then divide both sides by 2. And we get that y is 480. So if I bought 10 recycle bins, I could afford 480 garbage bins. Let's keep going up by the same value. So this time let's try 20. And what I'm going to ask you to do is go ahead and pause the video and you solve for 20. So do the same thing that I've done here and here. Substitute the value of x to be 20 and then solve for y. So hopefully you were able to do that and hopefully you found that y equaled 460. So you'll notice here that when I know my value of x, each time I have to substitute in and isolate y. A couple of things that we know about the relationship here is it's a partial variation because our initial value is something other than 0, and our initial value, or our y-intercept, is 500. And once again, looking at the original equation, there's no way to tell that that's our y-intercept. We can't know that looking at the equation. We also know that it's a linear relationship because we can see that our value here is actually going down. So our first difference here is negative 20. It's important to note for every 10 values of x, y goes down by 20, which basically means for every 10 recycle bins we buy, we can buy 20 less garbage bins. So we know the y-intercept is 500. We know the initial value is 500. We still don't know quite what the slope is yet. We could use a couple of values here to figure out what the slope is. Let's go ahead and try to do that next. So in order to do that, in order to calculate the slope, we're going to take two of our ordered pairs here. And it doesn't matter which two we take. I can take any two. So I'm going to choose these two here. So my second y value there is 460. So in the numerator, we'll subtract 460. And my first y value there is 480. So 460 minus 480. Since that's the direction I went in the numerator, I have to go in the same direction for the denominator. So my second x value is 20, and my first x value there is 10. And that's again just using these two coordinates here, 20, 460, and 10, 480. Well, when we simplify that, 460 minus 480 is negative 20, and 20 minus 10 is 10. So when we simplify that one, negative 20 divided by 10 is negative 2. So we've got our slope of negative 2. And again, we know our initial value is 500 from looking at our ordered pairs here. That's the y-intercept. When x equals 0, whatever the y value is, that's our value for b. That's our y-intercept. So we've got m and we've got b, so we know the equation in y equals mx plus b has to be y equals negative 2x plus 500. Well, let's take a look back at the original equation here. And again, looking at the original equation, we couldn't know what the slope is and what the y-intercept is. Now that the equation is written like this, we know the slope is negative 2, and we know that the y-intercept is positive 500. But looking at the original equation, we wouldn't know that. We know it's a linear relation because with the variables, all the exponents are 1. There's no variables in any denominators, and the variables aren't being multiplied together. So it is a linear relation. So what we're going to do is we're going to look at this original equation, and we're going to rearrange it. We're going to try to isolate y. So what we want to get rid of first is that plus 4x. So we're going to bring the 4x over to the other side. Now normally we would probably write 1,000 minus 4x. But because we always have y equals mx plus b, I'm going to put the x term first. So when I bring that positive 4x over to the other side, it becomes minus 4x. And this 1,000, remember, is positive 1,000. So it has to stay plus 1,000. Well, now I haven't quite isolated y yet. I have to get rid of that times 2. So to get rid of times 2, we divide by 2. And what's important here is we have to divide everything on the other side by 2. So we divide each of the terms by 2. Well, on the left-hand side, now we've isolated y, and now we can simplify. Negative 4 divided by 2 is negative 2, and we still have that x there. And then positive 1,000 divided by 2 is positive 500. So what we did here is we came up with the equation in a couple of ways. We started with an equation that wasn't written as y equals mx plus b. So we do have an equation of a line there. So initially what we did was we just came up with some ordered pairs, choosing some values for x and solving for y. We saw when x equals 0 what y was, so we knew what the y-intercept was, and then we used just the other two coordinates that we found to calculate the slope. That took quite a long time, whereas if I just rearranged the equation, isolated y, now we can look at this equation, and again we can see that the slope is -2 and the y-intercept is positive 500. Same thing that we got with the other method, but we got it by rearranging the equation. Well, suppose we had to find an equation of a line and all we were given were 2 points on the line. Well, now we know that an equation of a line can be written in a couple of different ways, but the way we want it written is y equals mx plus b. That's the way that we can get the most information from an equation of a line. So when we're asked for an equation of a line, well, we need to write it as y equals mx plus b, usually. And in order to do that, we need to know what the slope is and what the y-intercept is. Well, in the previous two videos, we talked about both how to get the slope and how to get the y-intercept. If we're given 2 points, we have an equation for slope that we can use, and that's y2 minus y1 over x2 minus x1. So we've seen this a few times now. I take my second y value minus my first y value, and in the denominator I subtract my second x value minus my first x value. -1 minus 3, if I subtract 1 and then subtract 3, altogether I'm subtracting 4. So that's -4, and then 7 minus 5 is just 2. And -4 divided by 2 is -2. So I've got my slope. So that means I can substitute that into this equation here. Instead of m, I can write -2. Well, the last piece of information we need now is the y-intercept. And as we talked about in the last video, to get the y-intercept, well, I can use an x and a y value. And remember, the x and the y in this equation represent coordinates. We actually know 2 of the coordinates here. We were given them right at the beginning. It doesn't really matter which one we use. We could use either one and we'll get the same answer. I'm going to use the first one because it doesn't involve any negatives. So instead of writing y, I'm going to write 3 because that's our y value there. And instead of writing x, I'm going to write 5 because that's my x value. Now we simplify as much as we can. -2 times 5 is -10. And we are trying to isolate b here, so we have to bring that -10 over. And now we know that the y-intercept is 13, or positive 13. So we know the slope. The slope is -2. We know the y-intercept now. The y-intercept is 13. So when we sub those values into y equals mx plus b, our equation is y equals -2x plus 13. So to finish off our introduction to finding the equation, I'm going to go ahead and get you to try a couple of questions here. So for each one of these questions, I want you to find the equation of the line written as y equals mx plus b. So you'll notice the first two questions, they're already equations, but they're not written as y equals mx plus b. So what you're going to need to do is rearrange those equations to isolate y. Get y by itself on the left-hand side of the equation. With the third and fourth question, I've given you 2 points on the line. So you're going to have to first figure out what the slope is, calculate the slope using our equation for slope, and then sub that into y equals mx plus b, sub in one of the coordinates, and isolate b. I'm going to warn you, the last question is going to involve some fractions, so you're going to have to be careful with how you're multiplying and adding and subtracting fractions there. If you're able to come up with the equation of each line there and state what the slope and the y-intercept are for each one, congratulations, you now have a firm understanding of an introduction to finding the equation of the line.